Hello everyone, this video is going to cover sections 3.1 to 3.4 in the textbook. This chapter describes the foundation of mathematical finance, and we will focus specifically on finding the fair price of forward and futures contracts. All right, so let's start with some definitions. So what are financial market instruments? Well, financial market instruments are technically divided into two categories. Okay, and here are the two categories: the underlying stock and their derivatives. Now, what are examples of underlying stock? Well, it could be the shares from Apple, Tesla, etc. They can also be bonds, like municipal bonds, and they can also be commodities. Okay. Commodities could be oil, gas, corn, gold, coffee, etc. The second category are called derivatives. Now keep in mind that this doesn't mean calculus derivatives. This is something different, but you will see the whole class. So a derivative technically promises some payment or delivery in the future, contingent on another financial instrument. Okay, which is referring to the first category. Okay, now there is a few derivatives. We're gonna see the whole class. The first we're gonna see in this chapter, they're called forwards, and then futures, and then we're gonna have options, which most of the class is gonna be based on this. So the future, you're promising to get a specific price in the future. So it's not very original, the name, but you'll see that at the end of this video. All right, so to recap, there is two types of financial market instruments: the underlying stock and their derivative. So the idea of this class is we're gonna have a specific derivatives. We're gonna start with forwards, and what should be the fair price of this, so that in the future you will get something, or you will deliver something. By that, it could be gold, gas, or a share of Apple, or a share of Tesla, stuff like that. We're going to start with a simple stock model, and there is a big assumption here. The assumption is that the stock prices, keep in mind again that a stock doesn't refer to only shares of Apple, Tesla, so stock could be any of this. So the assumption is that the stock prices at a fixed time t in the future are log normally distributed, where, for example, let's say that cat C has a normal distribution with mean mu and variance sigma squared. And remember, the density function was equals to 1 over the square root of 2 pi sigma squared e to the minus x minus mu squared over 2 sigma squared. Okay, we're going to use in the normal distribution a lot, so I highly recommend you to go to your 380 book and review it. I mean, we're going to do a quick review too in the class, but this is going to be very important in the future. So what does log normally distributed means? Well, remember T is the time in the future. So T is usually called the maturity time. So the time where you agree to do some transaction. And therefore log normal means the following, that the price of the stock at time T is equals to ln, or the initial price of the stock, plus some normal distribution. So this is what gives the price the randomness. Okay, so remember the ST means price of stock at time T. Now you do some basic precalculus. Notice that you take E in both sides. This should be equals to this, which means that ST will be equals to S0, which is the initial price, e to the, remember that S0 is the original price, or today's price. Therefore, this formula, which we're going to use multiple times in the future, is telling you that the price of the stock at time T should be related to the initial price times e to some random variable, which in this case is the normal distribution. And this is another way to say that the stock price at time T are log normally distributed. So this implies this. Last time we talked about the time value of money. So last time we talked about the time value of money. So now let's look to this equation, but let's take out the randomness out. So that should make this problem very simple if this is not random. So now let's say that you want in the future ST to be equals to 100. So this is what you want, say, in 1 year. So this is what is also called the future value. So the question is, what should be the present value of that, which will be S0. Okay, so we want the present value. So if we take the randomness out from this equation, from here we will have 100 is equals to E0 e to the RT, where here T is equals to 1. So therefore we have here T equals to 0, here we have T equals to 1. So the future value we want is 100. Okay. And right now, the price you solve for S0, this will be 100 times e to the minus RT, which remember T is just 1. So therefore this will be the present value. It will be 100 e to the minus RT. Now, as you can see, this is pretty easy to find because there is no randomness here. So it is replaced by this formula, and then this is pretty easy to figure out which is the present value and what will be the future value. All right, so now let's look to our first derivative, which is called a forward or a forward contract. So a forward contract is a contract between two parties, a buyer and a seller usually. Buyer and seller usually. where one party promised to deliver to the other party the stack, whatever stack he's selling, at time t in exchange for a specific amount. So they are agreeing to a price K right now, right? So the goal, and this is technically going to be the goal most of the class, the goal is going to be to find a fair, and we want to talk a lot about fair prices, the whole class. So the goal is to find a fair price for this contract, okay, where both the seller and the buyer will agree and will be happy. The forward contract is usually called over the counter, which means there is not a third party enforcing the contract. So this is just an agreement between two people. So therefore, there is no fee to get into the contract. Okay. So I'll give you a illustration right now, but technically there is no fee right now. You just have to agree on the price today. All right, so let's try a way to explain this, which is actually straightforward. All right, so here's a illustration. So let's say that Pedro has a gold bar right now, and let's say that the price of the gold bar today is $100. So the price today is 100. So Ethan wants to buy it in 1 year. The question is, what should be the price now, so that in 1 year Pedro will give the gold bar to Ethan, and Ethan will pay that money, which will be K. So Pedro is the seller, and he holds the short position. Okay, so you need to be careful with this terminology. Okay? And Ethan is the buyer, so he holds the long position. Now throughout the class, we're going to use f of s to denote the payoff function. Okay. So let's look to the payoff function for both of them, from the point of view from the buyer and the point of view from the seller. Now let's say that they agree, and we'll get to that later on, what should the value of K actually be. But let's say that they agree that K should be 120. So that means in 1 year, Ethan is gonna give Pedro $120, and Pedro will give Ethan the gold bar. Okay, so that's what they're agreeing to. So let's look to this from the point of view from the buyer and the seller, from both of them. Okay, and let's analyze the payoff functions. Okay. So K is gonna stand for the ST, and the y-axis is going to be the payoff function. Okay, so first let's look to the buyer, okay. And then this one will be from the seller. Same thing, this will be steam, f of s steam. Okay. Now let's say that K equals to 120 is right here. Okay. So therefore, let's say that in 1 year, the price of gold, which this represents the price of gold at time t, but let's say in 1 year, the price of gold is 120. Well, Ethan agreed to buy for 120, so he will make $0. Now, on the unlikely scenario that in 1 year the value of gold is $0, then Ethan will lose minus $120 or 120, because he already agreed he will buy for 120 in 1 year. So therefore the payout function will look like this. So from the view of the buyer, the payoff function is equal to st minus k, which technically is common sense. Okay, so for example, let's say that in 1 year the price of gold is 140. Well, Ethan will only pay 120, and he will make $20 automatically, which would be this 140 minus 120 will give you 20. So this represents the payoff function for the buyer. Now, what about the seller? If in 1 year the price of gold is 0, then the seller automatically makes 120, because they already agreed to that. He will give the gold, which is worthless now at this point, but Ethan still has to pay 120, which will be this case right here. But in this case, the seller will make 120. Now, if the value of gold goes over 120, then Pedro is the one that will lose money, because he will be selling something that is worth more than $120 for 120. So in his case, the payout function will look like this. Well, you can now go past the point. And in his case, from Pedro's point of view, the payout function is going to be now k minus st. All right, so it's very important that you keep in mind who's selling and who's buying throughout the whole class. All right, so we continue with the previous problem. So therefore, what is the actual fair price? Which technically this means there is no arbitrage. More of this on the next page. We talked about this last class too, to have a fair price, and we say that the law of large numbers should apply. Again, more on this later. So now first let's look at this from the point of view of the buyer. From the payoff function, the future value, okay, is going to be st minus k, okay, at t equals to n. For simplicity, let's say that n is equals to 1 for now, which means that the present value, okay, should be e to the minus r t. Remember that t is 1 times st minus k. This comes from the time value of money. Now remember that if you have a fair game, the expected value is equals to 0. So therefore the fair value should be the expected value of the present value should be equals to 0. Okay? Which this implies that the expected value of e to the minus rt times st should be equal to the expected value of e to the minus rt times k. Now, since r and t are now random, this implies that the expected value of st should be equal to the expected value of k, which is also random. So this means that k should be equal to the expected value of st. Now, in the forward case, okay, remember that here st is equals to S0 e to the RT. Therefore, this will be equals to the expected value of S0 e to the RT. But since this is not random, that implies that K should be equals to S0 e to the RT. Okay. Now you will see right now that you can actually derive this by common sense for forward contracts, but that's not going to be the case for more complicated derivatives. Now, in general, remember, in general, ST was equals to S0 e to the KC, where this is normal. So in this case, the expected, in this case, K will be equals to the expected value of ST, which would be the expected value of S0 e to the KC. Now the next result, we're gonna get into details of that much later, but technically this is the same thing as S0 e to the KC, where remember KC is a normal distribution with mean mu and variance sigma square. So if this is the case, then the expected value of this, and usually say this in math 380 or in some probability class. If you haven't, we will get to that much later in the class, but we'll get to it. For now, just take it as given. It will be equals to mu plus sigma squared over 2. Okay, so this will be general. Now, right now, since we're talking about forward contracts, the price should be this, which it should not be surprising, and let me tell you why. All right, so to make things pretty easy to see, let's say that in 1 year, so in 1 year, let's say that the interest rate is 5%. Okay, so therefore, if Pedro, so let's look from the point of view of Pedro first. So if Pedro sells the gold bar right now, he will get $100, and then if he puts that on the bank, in 1 year he will get $105.12. So therefore, the least he can expect to get should be 105.2. If he gets less than that, he can just sell it right now and put the money on the bank. So therefore, Pedro will not take any less than 105.12. Now, similarly, Ethan will come to the same conclusion, but in his case, he will not be willing to pay more than 105.12. So therefore, he will be okay paying at the most 105.12. So if this has to be more than, and this is less than or equal, and then more than equal, that means that the price should be 105.2. This should be the value for K. So in this case, K will be equals to whatever price is right now, e to the interest rate times time. So therefore, to price this, the interest rates are going to be very, very important. So far, we talk about fair price multiple times. So let's make that more precise. Arbitrage means that you want to make a profit risk-free, and this is guaranteed. Okay. So the idea of the class is to have arbitrage free. That is that there is no opportunities for risk free profits. Okay? So you always have to risk. You want to make a profit. Technically, you cannot get lunch for free. Okay? So the fundamental part of the class. So this is the fundamental part of the class. Is to find the arbitrage price. So the arbitrage price means that it's a price that allows no arbitrage. Okay, and this is what we're gonna call the for price now. And we did an example already. Remember, for the forward contract, the arbitrage price was K equals to S0 e to the RT. Right, let's try one example. And the problem says the following. A 1 year loan forward contract on a commodity is entered into when the commodity price is $40. So that means that S0 is 40 and the fixed interest rate of 10% with continuous compounding. So that means R is 0.10. Since the contract is for 1 year, then T is equals to 1. So the first question is, what is the forward price, or K? So remember that K is equals to S0 e to the RT. So in our case, this will be 40 e to the 0.1 times 1. And this is around 44.21. So therefore 44.21 is the arbitrage price. So this will be the arbitrage price. Okay. That is it. What is the initial value of the forward? Remember, the initial value is 0. Why? Because there is no premium. There is no premium to get into the contract. To get into the contract. Okay. Now, part C says the following. 6 months later, the price of the commodity is $45. So what is the present forward price and the present value of the original contract? Okay, so first, let's look to the present forward price. Okay, so now we're trying to find technically K2 so that we don't confuse it with the first K. So this will be S of 1/2. So the 1/2 means 6 months. And it will be e to the R T minus T. So in our case, it will be 45 e to the 0.1 or 0.10, and then will be 1 year minus T, which is now half. So this is around 47.31. Right, so now the new, which is the current price, so you need to keep track of that. This is what we did right now. This was 45 e to the 0.05 minus the original, which was 40 e to the 0.1. Okay, and remember this was 47.31 minus 44.21, which gives you 3.10. So this is the difference. So now if you want to find the present value of the original contract. So remember you had to do the discount. So in this case, this will be e to the minus r t minus t, and then the expected value, so it should be the expected value of st minus k2 minus st minus k, which is what we did here. So therefore, this will be equals to e to the minus 0.05 times 3.10. So again, this, same thing as this, or this, and this is equals to 2.95. So this will be the present value of the original one. Value of the original one. Right, let's try another example. So a 12-month long forward contract on 100 tons of wheat is entered when the commodity price is $145.05 per ton, and the interest rate is 0.05% with continuous compounding. So what is the forward price? Well, so this is what we have here. T is equals to 1, S 0 is equals to 145.05, and R is equals to 0.005. So therefore K is going to be equals to 145.05 times 100 times e to the 0.005 times 1, which is 145.77.7. Okay, so again, remember that this is the arbitrage price, which is obvious. Now this problem is very, very similar to the previous one, so just to make sure that you understand this. Now 6 months later, there is a shortage of wheat in the market and the price jumps to 151.96 per ton. The cost of borrowing also increases, and the interest rate now is 1.25%. So what is the new forward price, and what is the current value of the original long forward contract? All right, so here we have now that S or 1/2 is equals to 151.96. R is now 1.25, which is equals to 1.25%, which is equals to 0.0125. So therefore K2 is going to be equals to 151.96 times 100 e to the 0.0125 times 1 minus 1/2, because there's only 6 months left. Remember that this is equals to s to the 1/2, and this is around 15,291.27. So therefore the present value, okay, of the original will be the following. We use the same formula. It's going to be e to the minus r t minus t times st minus k2 minus st minus k, which in our case will be e to the minus 0.0125 divided by 2, okay, which is the same thing as this, times 15,291 times 0.27 minus 145 77.7 or around 709.1. All right, the last part of the problem says the following. Suppose that somebody agrees to enter a 12-month contract with a forward price of 14.50. So somebody agrees to pay this. Okay. All right. So what arbitrage opportunity does this create? And demonstrate this via an appropriate strategy. Okay. So according to what we did already, the arbitrage price should be this 145.77 or 14,577.7. So remember, we've found this to be the arbitrage price. Any other price besides this will create an arbitrage opportunity, which means a risk-free profit, and that's what I'm going to show you right now. Okay. So if somebody is willing to pay 14,500, then this will be the strategy. At t equals to 0, let's say that you are buying. This is what you do. At t equals to 0, you enter into the long contract. Okay. So technically you enter into the long contract with k equals to 14,500. So this is what you agree to pay in 1 year. So then you borrow. So here you see you can borrow and sell anything you want. So you borrow 100 tons of wheat and sell it. So if you sell it, then you automatically will get 145.05 times 100. So you automatically get 14,505. Okay. So then you're gonna put that money in the bank. Okay, so put the money on the bank. And since the interest rate is 0.005, you will get some money after 1 year, right? So that's what happens at t equals to capital T, which is currently 1 year. Then after 1 year, from the bank, you get 14,505 times whatever the interest you will get, which is around 14,577.7, which is the arbitrage price. Okay? Then you use the long contract which you enter, so the long forward contract. Okay. Then you buy 100 tons of wheat for K, which was 14,500. Okay. And give it to whoever agrees to buy for that price. And then your risk free profit will be 14,577.7 minus 14,500, which is around $77.70. And that's it. All right, so now let's look to futures. A future is technically a forward contract, which we already did in the previous pages, but that is traded in a formalized exchange. So that means that it is regulated by the government, okay, while the forward contract is just between you and somebody else, and it requires a margin, which is a deposit to make sure that you pay, and is a guarantee by a clearing house, which is the one that uses the deposit to make sure that you pay. Okay. Now let's look to the following definition, which we're going to use also multiple times throughout the class. To hedge means to protect a position against the risk of market movements. A perfect example of hedging was the example we did with Pedro and Ethan. So Pedro is trying to reduce his risk. If the price of gold goes down, he will be protected. If it goes up, it's not gonna good for him, but if it goes down, he will be protected. Well, Ethan, if it goes up, he will be protected, but if it goes down, he will not be protected. So that's what it means by hedging. Now, finally, remember that futures are technically forward contracts that are traded in a formalized exchange, and futures usually are used for three things. Okay, for three things. Number one, for hedging, which we talked about this already, so to reduce risk, like the example between Pedro and Ethan. Now, since futures are always traded in an organized exchange, like the Chicago Board of Trade, okay, they are highly standardized, which means it has to be very specific, like what kind of good they're trading, what quantity, what price, where will be the delivery day, and stuff like that. So because of that, futures are used to obtain information about the future prices of an asset. Okay, the future prices of an asset. Okay, so for example, let's say you're trying to build electric cars, okay, and you're gonna set up a factory where you will be building Tesla cars. Okay? But the factory will open in I don't know, 2 years. So you can now go to the Chicago Exchange and see what will be the price of lithium in 2 years. Okay, what will be the future price, and from there you can determine whether it will be profitable or not to open the factory in the first place. Okay? And the last use of futures is to speculate or speculation, okay, which is technically gambling, and we'll talk more about this later. And that's it.